Welcome back. We're working our way through lesson 5. This is video 5C. Going to talk about observational studies. And while I gave the punchline already, an observational study. It's a type of study in which individuals are observed, certain outcomes are measured. Let's get this on the board. Observational study. Individuals are observed, certain outcomes are measured. Here are the important points. There's no attempt to affect the outcome. You're just going online and finding data from your favorite sports team. You didn't manipulate anything. The data is already out there. No treatment is given. Let's think about treatments. Say that you're running a study for the FDA and they're evaluating 2 different cancer drugs. Some of the participants will get one of the cancer drugs and others will get the other cancer drug. That's what we would call a treatment. The researchers are trying to affect the outcome. Okay? This lesson is the opposite of that. We are just finding data that usually pre-exists. Okay? One might call this the hands-off method of obtaining data. A few examples here in the notes. One semester at the end, the professor notices that students who missed at least 3 classes performed much worse than students who missed at most 2 classes. The professor recognizes a pattern. The more absences students have, grades tend to get worse. It's an observational study. There's no manipulation of the data by the professor, right? No manipulation. The data that the professor is looking at, it exists. The person kept attendance records throughout the semester, final grades. We can make a scatter plot and look to see patterns, but this is definitely hands-off. Okay, the data exists. Another example. What do we have here? A team of medical researchers track many pregnant women. Over a number of years, there was a highly publicized 2008 study that found women who consumed 200 milligrams or more caffeine a day had double the risk of miscarriage, I guess when compared to those that abstained from caffeine. This is, again, an observational study. What can we say here? There's no random treatments. And let's talk about that for a second. I'm sure medical researchers would like to know if caffeine has an adverse effect on pregnancy. We can't recruit, say, 100 pregnant women, flip coins, and heads, we're going to give you 3 cups of coffee a day, and tails, we won't. And then at the end, we'll see whose pregnancies went smoother. Very unethical to do it. So when we want to investigate the effects of caffeine, we have to find data that exists, right? We have to find medical data, determine if women drank coffee at their own choosing or not, and try to make some conclusions based on that observational data. No manipulation of treatments, no random treatments. This, again, is an observational study. Maybe one more. My favorite example. Let's look at Major League Baseball. We'll call the 50s and 60s the golden age of baseball. We'll call the 90s and early 2000s the steroid age of baseball. And I don't know, let's decide which era hit more home runs per at-bat. Right? Discuss the details of using an observational study to determine which era had more home runs on average. Well, I could just go to the internet, try to put out a few notes here. Go online. Online baseball statistics, there are a zillion of them. We could actually take a census if we wanted to. It'd be more work. We could take every player that played in the 50s and 60s, find out their home runs per at-bat. We can take every player that played in the 90s and 2000s and do the same thing, right? So I'm not saying I would do this because it sounds like a huge project, but we could take a census. We could take a random sample as well. Take a sample of players from the 90s and early 2000s. Take a sample of players back from the golden age. Once we have our two samples, we would need to summarize that data. We know a little bit about that at this point. I would probably calculate, say, the average number of home runs per at-bat for the golden age. I would probably calculate the average home runs per at-bat of the steroid age. And if one is vastly different than the other, I'm guessing there are more home runs that were hit in the steroid age, but I don't know. I'd have to collect the data to find this out. Main point of this, we're using data that already exists. There's no treatments here. I'm not assigning certain players to take steroids, right? Again, to wrap this one up, we are using data that already exists. And because we're using data that already exists, again, it's an observational study. Okay. All right, if we flip over to the next page, there are some limitations of using observational studies. They're very common, by the way. You have to be careful with your conclusions. Okay? There's no randomization because no randomization has taken place. No randomization into different treatment groups has taken place. Really, we can only look for general relationships between the variables. Okay? We cannot prove, here's a very important bullet point, we cannot prove a cause and effect relationship when using this type of data, right? We cannot prove cause and effect relationships using observational studies. Between you and me, do steroids cause players to hit more home runs? I would say yes. Can I prove that to be the case, just finding some data on the internet from the 50s and 60s and comparing it to the 90s and early 2000s? I won't be able to conclude that steroids cause you to hit more home runs. The data might be biased, leading us to false conclusions. There might be lurking variables we haven't even thought about. And we'll get into this as we go back to each of the three examples. There may be lurking variables. We'll write them down on the next page, but I can already think of at least 5 things besides steroids that may have caused more recent players to hit more home runs compared to those back in the 50s and 60s. Right, let's flip the slide. Back to the 3 examples. The class attendance and final grade example. Can we say for sure that missing 3 classes causes your final grade to decrease? Easy, this is the 2-letter answer, right? Can I say for sure if you miss 3 classes that your grade goes down? I can't. What might be a lurking variable? A variable in the background that's sort of affecting grade and attendance. One I thought of, and there's a bunch here, but one thing I might say, students who skip class. Also, more likely, to skip homework. It's not the fact that the student has skipped class that has lowered the grade, but it's the fact that the student really doesn't do much of anything. Don't turn in take-home quizzes. Don't do online homework assignments. right? So there's sort of the student's personality that's floating in the background that's a lurking variable causing grade to decrease as well as causing classes to be skipped. All right, let's look at the second one. Our other observational study we looked at, this was the caffeine and pregnancy. With the caffeine and miscarriage example, can we say for sure that ingesting 200 milligrams of caffeine will cause your miscarriage rate to double? Can we say for sure just finding this data, this medical data? The answer is no. I can't say for sure that it was the caffeine. Again, name a possible lurking variable. And by the way, there are many possible answers to this. I'm not just thinking of the only lurking variable. One thing I thought of is that women who drink coffee during pregnancy might be more likely to also sneak a cigarette here or there, or even have a glass of wine. That personality type, again in the background, where they're willing to indulge once in a while, might be the reason for the miscarriage, and it wasn't the caffeine. Women who drink coffee might be more likely to also be smokers, let's say. Many of these medical studies where we're trying to look for causes of diseases, health complications, we have to rely on observational studies because it would be unethical to design an experiment, say, to determine if caffeine does cause miscarriage. All right, back to baseball. Last example of this video here. With the steroids and home runs example, name a few possible lurking variables. All right, I've thought of a bunch. I've taught this example many times. In the steroid age, I think players' nutrition, a lot better than back in the golden age. In the steroid age, I think players' training, exercise, equipment, all better now than it used to be back in the past. Right? So we have better equipment, we have better training, better exercise, etc. On top of the steroid factor from the 90s and early 2000s. And all of those things may have led to more home runs being hit. There's a few oddballs. I even looked them up on the internet. Most parks are a bit smaller now than they were back in the 50s and 60s. And they've also lowered the pitcher's mound. Back in the 50s and 60s, the pitcher's mound was higher. It was an advantage to the pitcher. Major League Baseball decided that there wasn't enough runs being scored, so they lowered the pitcher's mounds and advantage hitters. So all of these are possible lurking variables that would prevent us from concluding definitively it's the steroids that made ball players hit more home runs. All right, that does it for this video. Thanks for watching.